Hi everyone, how are you guys doing? Yes, shorts guy, don't worry. I'm going to take two reviews of this. Okay. All right. So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy where every concept of physics, chemistry, and maths are being taught to you completely in English. Unacademy is already India's largest online platform for IIT JEE preparation, and now we are bringing you the opportunity to study without the barrier of any kind of language in your learning. So before we get, this is a series that I'm hosting for class 12 students who are looking to give their JEE in 2021. So this is a quick revision series for all the topics that they have to go through. So here we'll be talking about the key concepts, and we'll also be talking about some previous year questions, okay, in these review sessions. So let's get started. Before we start the session, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for the JEE Mains and advanced examinations. Now, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. Now, I also qualified the NTSC Stage 2 examination, and I was in the top 1% in the NACP. Now, I've already coached many students to top ranks in the IIT, helped them achieve some dream ranks and go to their dream colleges. Now, all this teaching had been so far offline. So offline, I have really guided a lot of students, helped them to their dream colleges, and now I hope to do that with you guys here online. So as I said before, this year all my teaching had been offline. This year forced all of us to adapt to move to this new platform of online teaching. So that is what I had to do. That is what you also need to do as a student. Now, you know, IIT JEE is a highly competitive exam. So you can't afford to waste any time, and you can't afford to, uh, get risk your education or your preparation for this competitive exam to, lie back. So how can you make sure that your studies are going uninterrupted, and not only are you getting your education properly, you're getting the best education possible. That is what can be achieved with the help of the Unacademy subscription. This subscription will give you benefits like live classes, where you get to interact with your educators on a regular basis. These classrooms have live polls and leaderboards, which keep them highly interactive, efficient, and fun. Then you have test series and analysis sessions, and of course, you have live doubt clearing sessions. So these are the special features that you get with the Unacademy Plus subscription. So first of all, your studies are going uninterrupted. You're enrolled in regular courses, which are structured courses taken by professional teachers. Then they are supposed to be very interactive, and then you also have live doubt clearing sessions, which is a great feature. So every Unacademy course has this feature that after every three teaching sessions, one session has to be a live doubt clearing session. So what are you waiting for? Go and get the subscription. By the way, in case you want to understand or just experience some of the features, you can also do that free. So when you download the Unacademy app, you will realize that you have a lot of free classes. So first of all, let me also tell you that apart from all these benefits, Unacademy also provides you the opportunity to learn from the best teachers all across the India from the comfort and safety of your home. Now, as I said, how to get this subscription? So first step is installing the Unacademy app. Now you will realize even before you get a subscription, even if before you buy a subscription for yourself, there are a lot of features available for free. So you can get the experience of how it's going to be, when you and have enrolled or gotten the subscription. So first, install the app and go and attend those free sessions. So there are a lot of free courses on the app which you can just explore and experience, and then you have special classes which are free. So all these things can be experienced absolutely for free. First of all, okay, so you can first of all install this app, experience these courses and special classes, and see how it goes for you. Okay, so this you have to don't you don't even have to pay anything. Now if you like those classes, then what you can do is go ahead and get yourself the subscription, and this is how you do it. You'll need to go to the plus section of the app, select your goal as IIT and click on the get subscription button. Okay, and when you do that, you'll be redirected to the payment page, where you will realize that you can choose from two kind of subscriptions. One is the plus, and one is the iconic. The plus subscription is the normal subscription, which unlocks all the courses of Unacademy Plus for you. You can enroll in any course that you feel like being taught by any educator, and then you have another subscription, iconic, which will, if you want to take your preparation to the next level, then you can select this one. Okay, so and let me also remind you that you will have a box here which will say, do you have a code? So that is where you can use this code RD Live. You can also use this code to unlock the free features of the app. Okay. And once you apply this, you will get an instant 10% off on all your subscription fees. Okay, so let's see. Hi, ARJ, how are you? Good afternoon to you, Shorts guy. Hello, S. Pandey. Ethan D'Souza says, so does your Menadism playlist 9 lectures cover entire Menadics? Just asking, how did you finish it in 9 lectures? Because my teacher took like 19 plus 7 lectures. Okay, so I think first of all, 9 lectures are more than enough for covering Menadism. Okay, so I don't know how your teacher took 17 plus 19 plus 7 lectures. Do you realize if we take that kind of time, then we won't be able to finish the syllabus? Okay, so yes, I have covered all the topics in the playlist. Okay, uh, from Biot-Savart law, you have Ampere's law, you have everything. Then you have separate sessions for EMI. Maybe your teacher included EMI and AC also in Menadism. So I don't know how they were making those lectures. Okay. And Shorts Guy says, after gravitation, please take review on fluid dynamics. Absolutely, Shorts Guy. That is the plan. Hello, Amod Kumar. How are you? It's urgent for me to cover that chapter, so I can't sit for 19 plus 7. So I'm asking whether 9 covers the entire thing. Yes, Ethan. In fact, it does. In fact, it does. It does cover the entire topic. Okay, so don't worry. So if you open your HC Verma will have like 3 chapters on magnetism. Okay, and those are small topics. Okay, so yeah. Okay, Shorts guy. So yeah, sometimes that happens during the stream. The net fluctuates a bit. So Ethan, don't worry. If you're solving your HC Verma, you will realize if you watch all my lectures, you should be able to solve all the questions in HC Verma. Okay. So I think that should give you some confidence as to whether everything is covered or not. He took 19 for magnetism and charges, and 7 for magnetism and matter. Oh, okay. So I don't know how are you getting so much time? I don't know. That that many lectures? Okay. Okay, I don't know. I have been teaching professionally for past 8 years. So you realize in my offline setup where I used to teach, we had to complete the syllabus by October, starting from April. So in 6 months, if you're planning to cover the entire syllabus, I don't think we could have afforded that kind of leisure time. I don't know. Okay, so I sure not don't get how one can take those many lectures. Okay, so in any case, see, I have covered everything. I have covered everything in my lectures. If you watch those, if you try to solve your HC Verma, you will realize that you shouldn't be having any problem. Okay, absolutely not whatsoever. At the end of the lecture, can you tell me the problems to do from Irodov of thermodynamics and KTG? Okay, so first of all, Shorts guy, I do have Irodov line here, but I will have to take a closer look on the problems if you're asking. So give me one more time, one more day. Maybe tomorrow I'll tell you the problems that you should be solving from Irodov on thermodynamics and KTG. Okay. So moving back to our discussion. Okay. So I was telling you that don't forget to use the code RD Live, okay, to get this subscription. This will give you a 10% off. And when you click on proceed to pay, you will also realize that you have a lot of no cost EMI options available. So even if you feel that this fees is high, which trust me, it is not. I have been a part of offline setups. So trust me, here what you're paying is this amount. So for 24 month per month subscription costs you 2100. For 12-month subscription, the per month cost is around 2800, which is way less than what people pay in their offline setups. Okay, I have been actively part of offline setups. I have taught at some of the biggest brand names. Trust me, they charge you anywhere between at least 4 times to even 10 times the fees that you have to pay here. So this fees is definitely very competitive, and at these prices, this subscription is worth having. And if you still find that the amount is high, then you will notice that you have a lot of no cost EMI options available. So you can break this down into small payment parts, which will not bother you much. Okay. Now, talking about the iconic subscription. So, what is iconic subscription? What is so different about iconic subscription? So Plus subscription already gives you all the access to all the courses on Unacademy Plus. So why should one go for Iconic subscription? So this subscription will actually take your JEE preparation to the next level. So here in Plus, what happens is that you're free to choose any enroll in any course that you feel like. You can go for any educator, and it's completely up to you. In Iconic, you get assigned personal coaches. Okay. So you have from a team of professionals, you will be assigned a team which will closely mentor your performance and which will personally guide you through your IIT journey. Now, you will also be able to attend a lot of IIT JEE workshops, receive time to time expert guidelines, have a study planner for the entire 1 2 year sessions, and regular test analysis sessions. So trust me, this will give you more individual attention if that is what you're seeking for. Okay, so that is where this subscription, gets ahead of Plus. You get all the benefits of Plus, plus you're getting personal mentorship and personal guidance from the experts. Okay. Now, let me also tell you, in case you feel like, okay, I don't know, I'm not sure if I want to take those subscriptions or not, or yeah, I really want to, but maybe I don't know, the cost is too high. So there is another way of getting these subscriptions, by the way. So I hope you all have heard about the Unacademy Combat. Okay, so this is the most competitive and the gamified IIT JEE battle. Okay, now you can compete live in this. So this is an event where you're competing. So not only is it a good practice, it is also a good way of realizing where you stand in the competition, how your peers are doing with respect to you. So a lot of people keep asking me, sir, does Unacademy have a test series subscription? So no, there is no test series subscription, but here it is. You have these Unacademy combat kind of events which are completely free and open to all. So if you want to test yourselves, you can take part in these. So that'll be a good practice and great test of your performance compared to your peers. And if you do well, you will win yourself some really amazing prizes. There are a lot of cash prizes as well as subscriptions are being given away for free. Okay, so that is one way to get the Unacademy subscription. So make sure you're competing in this live and you can enroll with this code RD Live and rock the quiz and win yourself some cool prizes. So Jackson Nash says, oh, next time I will join 10 minutes late. Okay, Jackson. So everything has a cost, right? So you are getting such amazing content for free. So there is some additional information that also will not harm you. Don't worry, Jackson Nash. Okay. So again, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link so that you're receiving all the notifications of all the lectures happening here on the JEE English channel. All right, so finally, yes, Jackson Nash. As I said, trust me, no information is useless. Okay, even on those 10 minutes, we're only telling you something which will be useful for you. Okay, so in any case, you're getting all this quality education for free. No harm in knowing something extra, even if it takes just 10 minutes of your time. Okay, Jackson. All right, so getting started with today's topic, we'll be talking about gravitation today. This is quick review part one. So let's get started. So first of all, let's talk about the force of gravitation, what it is, what we understand by gravitation. So gravitation is a fundamental force between two objects having masses. So what do you mean when I say fundamental force? So when we say some force is a fundamental force, so there are four fundamental forces, I hope you know. Those are the forces that we consider to be the forces of nature. They exist fundamentally. When something exists fundamentally, then what we say is that it is just there. It is inherent in something. Okay, it is the inherent property of something. So, like every mass inherently has this property that it can apply a force of gravitation. Nobody has to make it do that. Okay, it automatically starts doing that. So that is why we call this a fundamental force. This is inherently there in all the masses. Okay. So I hope you remember there are four fundamental forces that we know of today. There are researches for a fifth fundamental force, but so far that has been inconclusive. The four are gravitational force. Okay, so four fundamental forces that we know of so far are gravitational, then electromagnetic, then you have weak nuclear and strong nuclear. Okay, these are the four fundamental forces Again, we say that these will be acting automatically. Nobody has to do anything for these forces to act. Externally, you are not required to do anything. So every force is related to some fundamental property of all matter. So gravitational force is the one which is related to mass. Okay, so if something has mass, then it can exert the force of gravity. That is what we understand. Similarly, electromagnetic phenomena are related to charges and so on. We don't really bother about the nuclear forces because both the nuclear forces, weak and strong, act within the nucleus for the subatomic particles. So in daily life, they do not really matter. Okay, but so right now, let's just focus on gravitational force. So as I said, this is a fundamental force of attraction between two objects having mass. Okay. Now, out of all these four forces, it is the weakest of all. Okay. So strongest being the strong nuclear, and then you have electromagnetic, then you have weak nuclear, and the gravitational force is in fact the weakest of the fundamental forces. Okay. Now, the mathematical description of this force was definitely given by the great Sir Isaac Newton in his universal law of gravitation. Now, Newton's findings would not have been possible without the works of many other scientists, and Kepler's laws were the main inspiration in getting those equations. Okay, so there were works of a lot of scientists like Copernicus. There were works of Galileo. There were works of Kepler that inspired Newton in his law. So the most significant related to gravitation is the work of Kepler. So we'll just talk about that quickly. So here it is, Kepler's laws. So what happened was that Kepler analyzed the sky charts. So at that time, there was a great obsession about sky charts and studying the sky charts and trying to find out something about the night sky. Okay, so there were a lot of sky charts that were given to Kepler, who was told to analyze those charts and come up with some laws. So after a long analysis of the night charts, night sky charts, Kepler came up with three laws of planetary motion, which become the basis of the entire gravitational theory. So let's talk about that. So after a study of years of data of charts of planetary positions, Kepler came out with just three precise laws. Okay, so trust me, it took a huge amount of time for Kepler to come out with these laws. I think it was more than 20 years, and you get to study them in less than 20 minutes. So you should appreciate the work done by all the scientists. So first law was the law of orbits. This law suggests that all planets move around the sun in elliptical orbits, with sun being present at one of the focal points. Now please note, before Kepler, people thought that all planets are moving around the sun in circular orbits. So Kepler was the first guy who pointed out that no, that's not the case. In fact, the planets are moving in elliptical orbits, and he also said that sun will be present at one of the focal points of that ellipse. Okay. Now, why does that happen? So if you think about it, actually what happens is you realize if every planet was just rotating about a stationary sun, then you have a problem at hand. What is the problem? So if you had that model in which you have sun present here at the center, imagine, and there was an orbit. Let's take of simplicity, consider a circular orbit only. So imagine if there was a circular orbit like this, and there were planets which were moving around this. So let's say this is Earth and this is moving around the sun. Now I have a problem. The problem is that if you consider the sun plus Earth system, imagine this is sun, this is Earth. If you consider the sun plus Earth system, then there is no external force on the system, correct? If there is no external force on the system, so the net momentum of the system should not change. So you realize when the Earth is here moving with some velocity v, the net momentum of my system points in this direction. Okay, this is the direction of p vector of the system. Agreed. Now, when the Earth rotates, let's say, and comes here, then what you realize is that when it is moving here, now the net momentum of the Earth plus Sun system points in this direction. So how is that happening? How is the net momentum changing its direction when there is no external force? So it turns out that model has a flaw. This model is flawed. And actually what happens is that when you consider the rotation of this, the Earth and the Sun, Earth is not actually rotating about the Sun. It's not revolving around the Sun. In fact, both of them revolve about a common center of mass. There's a common center of mass. This is the CM. Both of them will revolve around the common CM. Okay, in fact, the sun is also not stationary. You know that our entire galaxy is rotating about its own center where there's a huge black hole. Okay, hello Rajsi, how are you? So, anyways, so now we know a lot about this, but that is the thing. So, both these objects, sun and the earth, they are rotating about the common center of mass. That ensures that since the common center of mass will be stationary, the net momentum would always be zero. However, due to the huge mass of the sun is so heavy that actually that common center of mass almost lies inside the surface of the sun. Okay, the position would be less than the radius of the sun. Okay, so that is why it appears to be rotating above the sun, and that is why when you analyze that motion, you will get an elliptical orbit. Okay, the maths of that is not in your syllabus. You can't really find that out. But in your higher classes in your college, maybe when you study those, you will be able to derive that equation. Good evening to you, Mahiji. How are you? All right, so that's the first law that tells us something very, very important. And now we know the logic of this, that because it is happening because both Earth and the Sun are rotating about the common center of mass, and that is why you're getting elliptical orbits. And also because of the inverse R square law. Okay, so there are two reasons actually. Now, next law was the law of areas. Now, this law suggests that the line joining the Sun and the planet, very, very important, the line joining the sun and the planet sweeps equal areas in equal time intervals. Again, this was purely an observation from the analysis of charts. Kepler did not know the logic of that, but now we know the logic of this. We now know that it is a consequence of conservation of angular momentum. So let's quickly talk about that here. So imagine that a planet is here and it is moving with some velocity v, and at this time it is moving in a radius of small r. So you realize in time dt, it would have moved a small angle d theta. Okay, and so this d theta, how much will d theta be? D theta would have been b dt. That would have been the base of the triangle over r, arc length over the radius, right? Now, if you wanted to calculate the area swept by this, so what will be the area? Area you will know the A, that would be the complete, a complete, if I imagine that the radius almost remains constant in dt time, right? In dt time, we can ignore the variation of the radius. So I can say the area would have been, if the radius had not changed, then it would have completed one entire circle. Okay, and the area would have been here d theta over 2 pi into pi r square, correct? That is what you can say. The area of the entire circle would have been pi r square. And since only d theta part has been covered for the circle, so this would happen the dA. Now, what you do is you can replace this value of d theta over here. And when you do that, you will realize dA, the area turned, is nothing but v dt over r 2 into r square. So what you have is dA over dt becomes equal to vr over 2. Okay, now all you can do is multiply this with the mass of planet and divide this with the mass of planet. The upper term, mvr, is nothing but the angular momentum of the planet with respect to the sun over mass of the planet, 2 times the mass of the planet. Now, dA by dt is also called the aerial velocity. This is called aerial velocity. This law is important. A lot of questions have been asked from this equation. So this equation you must remember. It's called aerial velocity. So theoretical, direct theoretical questions have been asked from this in mains. That what is the basis of Kepler's law of areas? You know, it is the conservation of momentum, and this equation is very, very important. A lot of questions directly from this equation have been asked in JEE. Okay, so you remember that. The aerial velocity, which is the area swept per unit time, can be calculated as the angular momentum of the planet with respect to the sun over 2 times the mass of planet. Now you will realize during the entire rotation, since the force of gravity on acting on the planet, it acts like this. You realize with respect to the sun, the net torque acting on the planet is zero. That is why this remains constant. So I can say since the torque on planet with respect to sun is zero, so angular momentum of planet with respect to sun is always constant. So that is what your Kepler's law is also telling you. It is telling you that the aerial velocity is constant. You realize in that equation you have angular momentum of the planet with respect to the sun over 2 times the mass of the planet. Now, angular momentum is constant, mass of the planet is constant, so the aerial velocity anywhere in the orbit would be constant, which implies that when the planet is far away from the sun, it will move slower, and when it is closer to the sun, it moves faster. Okay, so that is a very important consequence, and pay attention to that. Remember that a lot of questions are asked from the previous equation. And then finally, you have the law of periods. So this law suggests that if T, capital T, is the time period of revolution of a planet and A is the semi-major axis. So please note, I hope everybody knows that any ellipse is characterized by a semi-major axis and a semi-minor axis, right? A and B. So if A is the semi-major axis, then Kepler noticed that the ratio of T square is to A cube is always constant, or T square is directly proportional to A cube, and this became the basis of Newton finding the inverse square law. Now we know that because gravitation varies as an inverse square law, that is why this equation works. Okay, so this was the basis, in fact, by which Newton could figure out that gravitational force has to vary with inverse square of the distance. Okay, so again, this is a very important formula. Again, a lot of questions are asked from this. Okay, so make sure you remember that E square over A cube equals constant for all planets. Now, please note that this formula is not only limited to planets moving around the sun. It is also going to be applicable for all satellites moving around any planet also. Okay, so whenever any celestial body is, or many celestial bodies are revolving around some other celestial body, then this ratio is always constant. Okay, so for all satellites of a particular planet, this ratio will be constant. For all planets with respect to sun, this ratio will be constant, and so on. Next, why don't we start with a practice problem? So here we go. So here you have been told that two planets at mean distances of d1 and d2 from the sun have their frequencies of n1 square and n2 square respectively. Then what is the relation between these quantities? So n1 square equals d1 square, n1 square d1 cube equals n2 square d2 cube, n1 d1 square equals n2 d2 square, or is it n1 squared d1 equals n2 square d2? So this is the question which has been asked previously in one of the entrance examinations. Okay, so we are taking up previous year questions only from various entrance examinations. Okay, so try and figure this out. Let's see if you can solve this. So this is a very simple, fairly simple question. So gravitation is a very easy topic. Okay, so you will have at least up to advanced level. The questions are very simple. At least the questions that are asked in mains are very simple. So very straightforward. In advanced level questions, you may have to think a bit, but up to mains level, I think questions are really easy. If you know all your formula, if you have had some bit of practice, trust me, all of these questions should be very easy to solve. Okay, so can we have some answers then? Let's see how many of you guys have figured this out. So, shorts guy, are you trying? Are you there? Okay, AP says D. Okay. Yeah. Okay. So you need to be careful, AP. You need to be careful. Okay. So Tanya is also trying. Let's see. So just use Kepler's third law. Hint. This question can easily be solved using Kepler's third law. Okay. So very, very easy. It shouldn't take that much time. Hurry up. Yes, B is absolutely correct. Okay, that is correct. So Kepler's law told you that p square over a cube is constant, right? Now you know nu, which is the frequency, is nothing but nu is 1 over t. So you can realize if I replace t as 1 over nu, then you will realize nu square times a cube would be constant. That's about it. That's about it. Yes, B is the correct answer. So since nu square times a cube must be constant, so B is the correct answer. Okay, n1 squared d1 cube would be equal to n2 squared d2 cube. Okay. All right, let's try another one. So you've been told, okay, so this is why I was telling you that that angular momentum formula was very, very important. Okay, this is another PYQ, previously asked question. Okay, so this asks you that if the ratio of the Earth's angular momentum about the sun to its mass is 4.4 into 10 to the power 15 meters square per second, the area enclosed by Earth's orbit is approximately how much? Okay, so try and figure this out. Try and figure this out. So how will you do this? Again, this is also has been asked. This also has been asked in mains previously. So think about this. Think about this. You know what you can find from the ratio of the angular momentum and the ratio of the mass, right? So think about this. So how many of you are trying? Let's see some answers. Come on. So this one requires a bit of calculation. Okay. So okay. But thankfully, you don't really have to bother much about the entire calculation. Just try and do an approximate calculation, and you should be fine. Okay. If you do an approximate calculation, also you should be fine. Yes, Amod Kumar says D. I think that is the correct answer. Well done, Amod. So just a little bit of calculation, and then there is absolutely nothing to this question. So I told you earlier, what is dA by dt? The aerial velocity. Aerial velocity is 1 by 2 angular momentum of planet with respect to sun over mass of planet. Correct. Now this ratio has been given to you. So this will become 1 by 2 into the ratio was 4.4 into 10 to the power 15, 4.4 into 10 to the power 15. So the aerial velocity is 2.2 into 10 to the power of 15 meter square per second. Okay, so that's the aerial velocity. Now, what has been asked of you? You have been told to ask the area enclosed by Earth's orbit. Now, how much time does Earth take to cover one entire orbit? So, time, I know, aerial velocity, I know. If I multiply those, then I can get my area covered. Okay. So, I know that time is 365 days, which is into 24 into 3600 seconds. Right. So, the area would be dA by dt, which is the aerial velocity, which is area square per second into the total time. Correct. So that is 2.2 into 365 into 34 into 3600 into 10 to the power of 15. So that will be your answer. Little bit of calculation, but if you do that, you should be getting D option as your answer. Okay. Now, if you wanted to do a slightly approximate calculation, so let's try. We can even try a slightly approximate calculation. So how do we do that? What I can do is, if I have to roughly have an idea, so I can make this roughly 2 into 25, right? These are the tricks that you should use. This into this can be roughly written as 2 into 25 into I have 36 whole square. So since the 10 to the powers of 10 are same for all, so all I need is the first term. So I only need to focus on the first term. So this will be roughly 50 times 36 square. Now, how about 36 square? How can you find 36 square? So you could have written that as 40 minus 4. 2. Okay, we'll wait for it. How can we approximate this? So I can roughly even write this as slightly less than 40. Okay, slightly less than 40 square. So 1500, 1600 would have been 40 square. So slightly less than 1600. So even if it was 1600, so even if this was 1600, I can say that this would be less than this. Now 16 into 5 would have been 9. It would be less than 9. So my closest answer should be 7. Okay, so that is the kind of calculation trick that I can use for such huge calculations. Okay, remember that would be a good way of approximating your answers. So you realize I can say that if I have to calculate this should lie somewhere between 50 into 30 square, okay, which would be 4.5 to 9, some value between 4.5 and 9, which should be closer to 9, by the way, because it is 36 square, right? So the only value which is closer to 9 is this. Okay, so again, remember, if you have too long calculations, then use these small approximations. Try and find the approximate value, so that will save you time. Okay. All right. So moving on to the next question, let's get some more practice. So if the distance between the Earth and the Sun were half of its present value, the number of days in a year would have been. Okay. So if the distance is reduced to half, what will happen to the number of days? Would you think? Let's see if you can solve this. Hmm. So this again should be easy. Again, try and find an approximate value in such questions. So these are all previous year questions. Okay. Now mains like to ask you such questions which are very heavy on calculations. Okay. But don't worry about it. Don't worry about it. Try and find an approximate answer. Okay. So let's see. Okay. D. No. Definitely not D. Okay. Let's see. So definitely not D. No, no. So try again. Try again. Try and figure it out. How much it should be. I think in this case it should be C. In fact, D you can straight away eliminate, by the way. D you can straight away eliminate. So all you need to do is in this question, use Kepler's law. Okay, so Kepler's law tells you that a t square is directly proportional to r cube. Correct. So can I say that T1 over R1 cube equals T2 square over R2 cube? Correct. So from here I can say T2 should be equal to T1 times R2 over R1 to the power of T by 2. Correct. What do you think the answer should be? So solve it quickly. Let's solve it quickly. This is what you have to find the new time period. The original time period is the length of the year correctly is 365 days. So you will realize T2 would be equal to 365 into 1 by 2 to the power of 3 by 2. Okay. So definitely it will be less than 365. So I can immediately eliminate this one. Now all these are less than 365, and I can definitely say, since this is 1 over 2 to the power of 3 by 2. So can I say that T2 should lie somewhere between 365 by 4 and 365 by 2. Okay, so that's the trick that you can use. 365 by 4, how much is that? That is 90 something, right? 91.25. So I can from here say that 91.25 to T2 should be equal to less than this. So that will be 182.5. Agreed. So I got the range of T2. It has to lie between 91.25 and 182.5. So let's see. It this cannot be the answer. This cannot be the answer. The only answer is option B. Okay. So yes, 129 is the correct answer. Now that is the point that I was trying to make. You do not have to make the exact calculations. So mains people will ask you such calculation heavy questions. Again, you realize if it is 365 upon 2 to the power 3 by 2, then it has to be definitely less than 365 by 2 and greater than 365 by 4. So these kind of things you can use to avoid wasting a lot of time to finding the exact answer. Okay, since I'm getting this, only one option lies in this range, and this calculation is super easy. It is 365 by 4 is super easy to calculate. 365 by 2 is super easy to calculate. Whenever you have such a problem, see, you realize that 2 to the power 3 by 2, calculating that, you might want to waste a lot of time. Now you can avoid that by using this. Okay, so that is how you should approach your mains calculation heavy problems, calculation extensive problems. Okay. All right. So that is what I wanted to talk to you about the Kepler's laws. Now let's move on to Newton's law of gravitation. So now this is one law that is called the universal law of gravitation. Why? So why do you have such a special term associated with it? So not many laws will have this term universal, connected to them, because this is one of the greatest laws that we have in the human history, and this is universal, meaning that this can be applied anywhere in the entire universe, wherever you go, whatever masses you pick, whether you're trying to calculate the force of gravitation between an electron and a proton, or two electrons, or between a sun and a planet. This law can be applied across any scale, across anywhere in the universe. ESAPB was the correct answer. All right, so let's talk about it. So again, every mass. This is the exact language of Newton's law, which he presented in along with his laws of motion. Okay, so Newton's law says that every mass in the universe attracts other mass with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Okay, so that is the law. And again, mathematically, this law was given as F equals a G times m1 m2 over r square. Okay. Now G is the universal gravitational constant. Okay, universal gravitational constant, and its value is its value is 10 to the power minus 11 in SI units, 6.67 to 10 to the power minus 11. Okay. In fact, Newton did not know the value of G. Newton, when he gave his law, he just left G as it is. The value of G was found by Cavendish much later in early 1800s. Cavendish did this experiment and found the value of G. Okay, so for almost 100 years, nobody knew the value of G. Okay, so that's a great thing. Now, please note that this law is only defined for point masses. A huge mistake that a lot of students make. They don't understand that. They don't realize that. So when I ask them, so this is a common mistake that all my students have made in the past. So I told them that this is a mass m1. Consider this another mass m2. Now, what will be the force of attraction between them? So they would immediately say that it would be sir g m1 m2 over r square. And when I ask them what is r, then they would I have gotten some really weird answers. The most common answer that they give is that r is the distance between center of mass to center of mass, which is wrong. This is wrong. Okay. So, in case you still thought that, then please correct your knowledge. This law is only defined for point masses. You cannot apply this law for bigger objects. Okay. So, please note when you're talking about point masses, then there is no confusion at all. Okay, so you have one point mass here, you have another point mass here. So clearly there is only one r between them, and this would have been the r. That's it. So when you're applying this law, make sure that you're only doing that for point masses. Okay. Now moving forward, we can discuss the vector form of the law. Vectorially, this law can be written as force on object 1 due to 2 would be minus times g m1 m2 over r square times r of 1 with respect to 2, where this is the position vector of m1, position vector of m1 with respect to m2. Okay, so I hope everybody's clear about that. Similarly, if 2 on 1, force on 2 due to 1 would be given as, can be given as minus of this. So you realize that this law obeys Newton's third law. It also obeys superposition principle. So what do you mean by that? So this law was only defined for 2 point masses interacting with each other. So in case you have multiple point masses, so you have m1, m2, m3, m4, and so on. So what you can realize is that if you're finding the net force on m1, then all you need to do is find the forces due to individual masses. So due to m2, due to m3, due to m4, and so on, and vectorially add them. You can vectorially add them. The net force would be superimposition of all the individual forces. So that is what the superposition principle says. Okay, now let's get ourselves some practice again. So here you have been given a total mass m of capital M. How should the two masses be divided so that gravitational force between them at a given distance is maximum? So you want to divide this mass capital M into two parts. How should you divide this into two parts so that the force of attraction should be maximum for a given distance? Okay, so what should be the two parts? So let's see. This is an easy one again. They should be giving me some very quick answers for this one. Okay. So hurry up. Let's see if you can get this. Again, a very easy one. Should not be difficult at all. Let's see some answers. Okay, so Tanya is trying. All right, people. Do you guys try? Till then, I'll help myself with some water. In case you don't know anything, the easiest way is to check out the options, right? In case you can't figure out how to calculate this, you can always see it from the options. And that is how the mains questions are. You can figure out a lot of mains questions just by looking at the options. Okay. D, absolutely. D is correct. D is the correct answer. Yes. Well done. Okay, so you just need to remember what was the force. Force of gravitation was G m1 m2 over r square. So all you want to do is maximize this term. And you should know that okay, this is a standard result. In case you did not know, now you can remember this. This is a very standard result that if a plus b is constant, if a and b are two numbers which can be taken such that a plus b is constant, then a into b is maximum, and when a equals b equals c by 2. Okay, so this is a very standard result. So Om Prakash Tiwari wanted to write something and then he retracted his messages. Okay, what happened, Om? Okay, this is a standard result. Again, you can use this. You remember this standard result, which we use a lot. So you can remember this. So yes. So since you know that here m1 plus m2 is constant, right? M1 plus m2 equals m, which is constant. So m1 into m2 max would be m square over 4 for m1 equals m2 equals m by 2. Again, you can prove that by differentiation also. Okay, so not a big deal, not a huge deal about this result, standard result, which you can easily derive. But since this is a very commonly used thing, so you can remember this. Okay, so the correct answer would be D, in fact. Okay. Otherwise, if you could not figure it out, if you were in a real hurry, so you realize if this product is maximum, then the force would be maximum. So you could have just multiplied these. If you multiplied these, this was 3 by 16 m square. If you multiplied this, this was 2 by 9 m square. If you multiplied this was 4 by 25 m square. And this would have been m by 4 square by 4. So you realize this is 3 by 16 and 1 by 4 is 4 by 16. So obviously this is lesser. So this is 2 by 9. 1 by 4 is 2 by 8. This is definitely lesser. Similarly, this is 4 by 25. 1 by 4 can be written as 4 by, okay, 1 by 4 can be written as roughly 6 by 26. Right? 24. Yeah, so this will be lesser. Okay. So that is what you can do. This is less than 1 by 5 also. This is less than 1 by 5 also. So this is definitely lesser. This is the greatest of them. So this can be the answer. So again, make sure not only you know your questions. In case you don't know, then you can use some common sense and get the answers. Okay. All right. Let's try one more question then. This question says that three identical point masses, each of mass of 1 kg, lie on the xy plane at points 0, 0, 0, zero point 0.2 and point 0.2, 0. The net gravitational force on the mass at the origin is. Okay. So you have three forces here. Find the net force acting on the mass at the origin. Let's see if you can figure this out. Okay. So again, an easy one. Again, gravitation is the kind of topic where a lot of questions that are asked are very, very calculation extensive. So that's why a lot of students don't like attempting these. But I'll tell you small tricks that you can use for those calculations. Maybe I'll take an entire session for that. So that would help you, because in mains you may have a lot of questions which are using extensive calculations. So how to avoid those kind of calculations and how to find the correct options without having to do too many calculations. Let's see. How about this one? What do you guys think the answer for this one is? So think about this. Think about this and let me know. AP says B. Okay. Okay. That might be correct. So first of all, even before doing any kind of calculation, what you can do is, even before doing any kind of calculation, just think about this. Think about this. So you have three masses, correct? So let's just draw those three masses. One is here, one is here somewhere, and another is here somewhere. Right. So so this is at 0, 0, 0, 0. This is at one was at 0, 0.2 and 0.2, 0, 0. 0.2, 0, and then you have 0, zero point. So first of all, you should immediately realize that the force, this guy will be attracted to this guy will be attracted to this. Okay, so both and since both the masses are equal and are at the same distance, so obviously I and j component would be equal. So I can immediately say that the net force has to be I plus j in the direction of I plus j. That is what I can immediately say. F should be equal to something into I cap plus j cap differently. Okay. C and D is eliminated by seeing. Exactly, Aniket. That is what I was saying. That you can easily, immediately eliminate these two. Okay. So that is what I was telling you, that you should use some common sense. In case you're running out of time and you got this problem, immediately you know options A and B. So you can take a gamble here. Okay. So even without calculation, you could have just reduced it to two options and then gone for any one of them. It would, in case you did not have any time, by the way, only in case you did not have any time. However, now I know, let's call this F1 vector and this F2 vector. So both of them will have equal magnitudes. Okay. So F1 mod would be equal to F2 mod. And how much will that be? That would be G times M1 M2 over R square. Correct. So I would have had 6.67 into 10 to the power minus 11 over R square would have been 4 into 10 to the power of minus 2, right? Now, the net force. So I think this would be 1 point something, right? Then how to solve? By checking the dimensions. So see, that cannot be applied anywhere. Like in this kind of question, you cannot check for dimensions, right? I think I discussed one question from rotation, which you could have done with the help of dimensions, or was it EMI or AC, something like that. So A is the correct answer. In fact, absolutely, A is the correct answer. So just a little bit of attention, and you will immediately get your options right. Okay, so I think you guys missed something. Okay, so the answer is in fact A. Okay, yes, Aniket, you are absolutely right. So again, Ethan, you can't apply dimensional analysis everywhere. So not in this question. So that will help you only for a very few selective problems. So none of these problems could have been done dimensionally. See, again, all these equations are also dimensionally homogeneous. Okay, so a very few problems can be done with the help of dimensional analysis, and there also you should see how my options are. So, like for instance, here also you will realize that the dimensions of all these would be exactly the same. Okay, so I think I had even one question where you were supposed to find the EMF, I think, or I don't remember the force. I think the force. Yeah, it was in EMI. Now I remember. In that question, there were options of V square L square V or something like that over something 2R or something, and options were B L V over R. So if the options have different dimensions, then you can use dimensional analysis, Ethan. Okay. What essentially you can do is that you realize that this has the dimensions of current. So if the current was asked, then out of these two, this has to be the correct answer, right? And this would be the I think power. It would have become V into I. Yeah, if you have this, then the voltage, the EMF was BLV times current. That is power. So if your power was asked, then you could have gone for this. So that is what you do in dimensional analysis, Ethan. Okay. I hope you follow this. Okay. All right. How about this question, however? In here, I can't use dimensional analysis. So I can only use dimensional analysis when all my options have different dimensions, right? Or at least two, three of them should have different dimensions. If everybody has the same dimension, all my options have the same dimensions, then the dimensional analysis would be of no use. In fact, if your options have numbers, then also you can't apply dimensional analysis, correct? So here is a question which says four particles of masses m, 2m, 3m, and 4m are kept in sequence on at the corners of the square of side A. Right now, you have been asked the magnitude of gravitational force acting on a particle of mass m placed at the center of the square. Okay, so again, very interesting. So try this, try this. So definitely it can't be zero. Okay, so one option eliminated. Just by looking at the options, you can eliminate D. So zero definitely cannot be there. Now root 2 should be there. So if I had to take a guess, I would have immediately gone for C. Without even having to do any calculations, I would have immediately gone for C. Because in my opinion, there should be a root 2. Okay, so there is square on which four particles are kept, and you have to find the magnitude of the force acting at the particle kept in the middle. So you realize if you just draw a mental picture also, if you draw a mental picture also, then you could have just solved this. Imagine here, 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 and here. These are the four masses that you have, right? Hmm. So what has been asked of you? You have been asked to calculate the force on the particle in the middle. Okay, so if you just gave it a little thought, you would have realized that see these two forces have to be perpendicular to each other. You have mass here, you have mass of m, 2m, 3m, and 4m. So let's start from here: m, 2m, 3m, and 4m. Correct. What you will realize is that both these guys are pulling it towards each other, and both these guys are pulling it towards each other. Now you realize because this distance would be equal, all these distances are equal. So I can what I can say is that I can write this 3m as 2m plus m, right? 2m plus m. So this the force due to this m and this m would have gotten cancelled. The net force would have been due to 2m towards this side. Okay, so the net force should have been in this direction, some f. Similarly, here also I can do the same thing. Here also I can write this as 2m plus 2m. Now 1 2m would have cancelled the force of this 2m, and I would have had the same magnitude in this direction, f in this direction. Now you realize they are both at 90, so the net force would have had f root 2. So since no other option has root 2, so option C has to be correct. Okay, that I can tell you without even calculating, without even doing any calculations. Okay, from a mental picture, I could have told you. If I do a mental picture and I know one force has to be along this line, this diagonal, one force has to be along this diagonal, and both of them will be equal. So there has to be a root 2 in the net answer. Now we can verify that also. We can verify that also. So you were told that the side of the square is A, so the length of the diagonal. So I can simply say that this F, what will be F? F would be, what is the force at the center is M. So that would be G times 2M into M over half the diagonal squared. Yes, yes, Om Prakash. Absolutely correct. So half the diagonal squared. So half the diagonal would be A by root 2 whole squared. So F I am getting as 4gm square over A square. So F net would have been F root 2. So that would have been 4 root 2 gm square over A square. Okay. So yes, in fact, I did get that answer. But you realize this is what happens in mains questions. In mains, they give you very nice options. So in mains, if you're just a little alert and if you're just paying a little bit attention to the options, then you can immediately mark the right answers. Yes, 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 absolutely correct, Om Prakash. As I said, when I looked at the options, I immediately knew without even calculating. It has to be C. No other option can be possible. All right, so that was about Newton's laws. Now let's start our discussion about gravitational field. So what's gravitational field? So let's talk about that. So again, the mechanism of action of this force, which is acting from a distance, was explained with the concept of gravitational field. So we got the idea of fields to explain the action of all these forces which act from a distance, right? So you have electrical forces, you have magnetic forces, you have gravitational forces. All these forces can act from a distance. So how do you know how is this pen applying a force on, let's say, my hand? So how is it able to do that? So we came up with the idea of fields. We said all masses produce gravitational fields, all charges produce electrical fields and magnetic fields, and it's the fields that apply forces on different objects. Okay, gravitational field at any point will have what effect? It will be able to apply force on a mass, right? So if the effect is to apply force, then how to measure it? The way to measure it should be the amount of force. If this pen can apply double the force compared to another thing, so I can say its gravitational field must be doubly strong, right? That is the definition that we give for a gravitational field strength. The gravitational field at any point is defined as the ratio of the gravitational force to a test mass placed at that point. Okay, so wherever you want to find the strength of the gravitational field, I essentially refers the gravitational field intensity. Gravitational field intensity can be defined as the force experienced by a mass m to over the mass itself. Okay. Now, gravitational field is not just a mathematical entity. So, when people came up with the concept of these fields, they were just an idea to express, to understand how the forces must be acting. We were not sure initially whether these things are real, they are real physical quantities, but over a period of time, experiments show that yes, these fields are real, they are real physical quantities, and all masses interact through fields only. These fields follow principle of superposition as well, and these fields travel at the speed of light. Okay, so that is not mentioned here. That is probably not even discussed much in your syllabus, but that is what I wanted to tell you. These fields carry energy. These fields travel at the speed of light. So they are real physical quantities. Okay. Now we will just focus on the calculation of gravitational field. Now, due to a single point mass says gravitational field can be easily calculated using the Newton's law. So Newton's law will tell you that the force, if you put a test mass here. So if you wanted to find the gravitational field of this, you put a test mass here, and this is your mass m, because of which you want to find the gravitational field here at a distance r, and let's say the position vector of this is r. So I vector would have been g m m r over r cube into 1 by m. This is how you would have found the gravitational field to a point mass g m1 over r square r cap. That is also another way of writing it. So this is the vectorial form. Yes, if you wanted to write the magnitude would have been gm over r square. Absolutely. Okay, so that is how you could have measured the gravitational field intensity. This is very, very simple. Now, once you know the gravitational field intensity due to a single point mass, now if you had to find the gravitational field intensity due to a continuous mass distribution, then I vector would have been equal to integration of dix I cap and plus di y j cap plus diz k cap. Now, please remember whenever you're performing integration over vectors, you perform integration over the components, not for the whole vector. Why so? Because integration is scalar addition. So you cannot add vectors like scalars. You can, however, add all the x components like scalars, all the y components like scalars, and all the z components like scalars. Wherein you can obviously find the di vector also. Okay. So di vector would be for any point mass, it would be given as gdm over r square r cap. Now you can divide this into x, y, z or whatever if you wanted to calculate it in the r direction only in terms of r and theta. You can also do that. So the net I would be actually the integration of this. I can also say I vector would be integration of this. Okay. Now again, since this is all in r cap, if the r cap is the same, then you should be fine with this. Okay. So write the gravitational field due to a single point, which will be g dm over r square, and then integrate that. Okay, that is how you find it. Now we will talk about the most commonly used results, which are the gravitational fields due to a hollow sphere and a solid sphere. So for hollow sphere, you should know. I'm not again. We are not going to show the derivation for a hollow sphere. For a hollow sphere, you will realize if this has a radius r and you wanted to calculate the gravitational field intensity at a point r which lies inside. So for small r less than r, you realize I vector would be 0. So there is no gravitational field intensity inside a hollow sphere. And for r greater than r, you would have realized that I would have been g m over r square r cap. So if m was the total mass of this. So for any point outside the shell behaves as a single point mass kept at the entire mass being kept at the center of the shell. And for any point inside the shell, the gravitational field intensity is 0. Again, we're not going to talk about the proofs of this. Now, for hollows, for solid sphere, you will realize that the equations become for r less than r, you would have had I vector equals gm small r over r cube times r cap. Okay, again, not showing you the derivation. If you want to see the derivation, you can attend the lectures when I take them for class 11. Okay, this is a revision class, so we are just quickly going over the formula. And this again, of course, becomes gm over r cube r square, small r square, in fact. Okay. For any point outside a solid sphere, the sphere behaves as point mass kept at its center. For any point inside, you will see the gravitational field intensity to be increasing linearly with respect to the distance from the center. Now, you can also draw graphs of this. So please note that these graphs are very important. A lot of times, IIT JEE likes to ask you questions on graphs, so you should be aware of these graphs. Graphs are very, very simple. Once you know the equations, okay, you shouldn't have any problem in drawing the graph. Let's this let's have this. So if I'm talking about the magnitude, then I'll have one graph. If I'm talking about the vector, then I'll have another graph. Please note. So here, if I want to, let's say I'm drawing the graph between the vector, I vector is too small r. So initially the okay, Shivansh, I don't know. At r equals r, both of them are equal, right? At r equals r, both of them converge. Okay, so you can use equal to also in both. Doesn't matter. Oh. Sorry, not here. Here it is not defined. For hollow sphere, you cannot be at the surface of the sphere where there is mass. Okay, so since not two masses cannot occupy the same position, so there is no lag as such. Shivansh, I am watching the stream. Okay, the stream seems fine. Okay, and here you will realize both these formulae converge actually. Here both these formulae converge. Okay, and here the in the above for hollow sphere the formula is discontinuous. So you know the left limit, you know the right limit. Okay, at R you do not talk about it because at this surface you do not want to actually know also because mass is already present at the surface. There cannot be any other mass present there. Okay. Now, how does the variation look like? Let's see. Is it fine now, Shivansh? Yeah, that's what I was thinking. That's what. Yeah, because that is why I keep my own stream on. I keep looking at it to realize. So this you would have seen, this you would have seen would have been 0 till up to R. And then from R, you would have seen it go like this. This is what the graph would have been. Okay. Now, please note that this is I vector. That is why I'm showing it in the negative axis. Why? Because you will realize everywhere. Okay, so I completely forgot about this minus sign. Everywhere there will be a minus sign. Right? I hope I put here also. Yeah, I've been forgetting the minus sign. Right? Gravitational force is attractive, so the intensity vector would point towards the negative x-axis on the positive side. All right. Similarly, for a hollow sphere, how would the variation have been? So till here, it would have grown like this, then it would have fallen like this. So after this point, you realize that the variation for both would have been the same. Okay. So this is what the graphs would have looked like. Okay. Very easy, straightforward graphs, straight line graphs from 0 to capital R and then falls hyperbolically from capital R to infinity. Oh, well done, Shivam. Good to know that. Well done. All right. Again, you should be remembering these graphs also, and always pay attention to the language. Whenever they tell you that the magnitude of field intensity is to be plotted, then you would have had this in the positive side. If they tell you that the vector of field intensity has to be plotted, then you would have been made it in the negative side. Okay. Okay, that's great, Shivam. I'm happy for that. So I think today is your doubt class, right? On Plus. So you can come, make sure you come today in the doubt class and get rid of those three doubts also. Okay. All right. So let's move forward with the discussion. So why don't I give you guys some practice then? Let's give you some practice. So here is what you've been told. So a mass of small m is placed at a distance of r from the center of a rod of mass capital M and a length L, as shown in the figure. Now, the gravitational force on the small m mass due to the rod is. What will this be? Try this. Try this. Interesting problem. Now, again, here also, if Ethan was here, I don't know. Here also, you realize dimensional analysis won't help you. Because dimensionally, I think only two options can be eliminated. Two options can be dimensionally eliminated rather. So yeah, you realize that this and this are dimensionally incorrect. Okay, because they have G m1 m2 over r cube. ये मेरे एग्जाम का क्वेश्चन था जिसके लिए आपसे टिप्स लिए थे. Okay. So if Ethan was here, that is how you could have seen it dimensionally. So dimensionally, it has to be one of the two, and obviously, it should not be one because one is for a point mass. So if I had to choose, I would have immediately marked B. So that is how you can just look at the options in mains. This works. Trust me, in advance it won't. In advance it won't. Advanced questions are not so easy to solve just by looking at options, but in mains it works. So from dimensionally, okay, so no. Dimensionally also, these are also correct. Wait. I did not notice that. Yes, there is R here also. There is R here also. So again, dimensionally, they are all correct. Hmm. So tricky problem here. If this was not here, suppose if this was not here, or if this was not here, then I could have eliminated these using dimensional homogeneity. Okay, and then from A and B, I know which one to select. Only option B can be correct. It just makes sense. So, but no. Life is not that easy. Also, hmm. So turns out dimensionally, all the four options are dimensionally all right. Hmm. So try this and let's see if you can still solve this. Okay, I want everybody trying this. Now, please, again, option A has been kept there because a lot of students make this mistake, which is that they can say, okay, put the entire mass of this at its center of mass. Right? That is wrong. That is wrong. You cannot put the entire mass at the center of mass and calculate the force between the two. So that is why option A was included. So if somebody has the wrong concepts, they would have immediately gone for A. Okay, this is easy. Put the entire mass of the rod at its center of mass. And then you have 2 point masses. Apply G m1 m2 over r square. Which is wrong. So how do you solve this correctly? So anybody giving me an answer? Or should I just solve this? Let me know. So let me know. Do you know how to solve this? So remember what we talked about. All right, let me just quickly solve this. So imagine. Okay. So here I will need to integrate. Okay, so this is rod of length L. Okay. So length is L, mass is capital M, and the other point turns out is at a distance of R here, and here you have another point mass, right? So if I can find the gravitational field intensity due to the rod, चार हो गया काम टेस्ट में यही काम कर आया मैं आप तो भाई ध्यान दिया करो जब बातें बताई जाती हैं अच्छा यू आई हैवंट टॉट यू ग्रेविटेशन राइट सो दैट इज व्हाई यू मेड दैट मिस्टेक हम्म ये जब मैं डिस्कस करता हूँ आई दैट्स द फर्स्ट थिंग आई टेल स्टूडेंट्स because I know a lot of students okay Om Prakash says it's D let's see all right I got that now let's see so what we are going to do is that let's assume that okay, so from the center, let's take a point which is at a distance x and has a thickness of dx. Okay, and let's try and calculate the gravitational field intensity due to this. The gravitational field intensity due to this would have been, when I say di, would have been g dm over r minus x whole square. Yeah, so that would have been the gravitational field intensity. And what is the direction? The direction would have been I cap, right? This would have been the direction of di. And all the di's would have this direction. So this I can integrate. Yes, dm would be m by l dx. Absolutely correct. So I think yes, I think Om Prakash has done this correctly, I'm sure. So di becomes g times m by l times dx over r as x whole square. So all you need to do is integrate this. And when you integrate this, the limits of x would be put from minus x by 2 to plus x by 2. correct? So what is the integration of this? The integration of this would have been Gm over L, and the integration of this would have been r to the power of minus 1, and then you would have had two minuses. So that is it. Okay, r minus x to the power of minus 2, when you integrate that, you would have had r to the power minus x over minus 1, and then because there is a negative here, you would have had another negative sign. So those two negatives would have cancelled each other. F equals G m1 m2 over r square. Okay. So when you integrate this, what you're getting is Gm over L, and here you are getting 1 over r minus x by 2, L by 2. Okay, sorry, L by 2 to plus. The limits would go from minus L by 2 to plus L by 2. Let's just quickly correct that. Okay, so I would have had a 1 minus L by 2 minus 1 over r plus L by 2. Right? So if I solve this, I should have gotten, I should be going Gm over L. Then when you take the denominators, you would have had r plus L by 2 minus r minus L by 2. So you would have had L here over r square minus L square over 4. Okay, so that is 4Gm. L and L get cancelled, and I have r square, 4r square minus L square. So this into small m would have been the answer. So Om Prakash, it's not D. I think I missed a 4 here, but the answer is B. Should have been a 4 here. And the answer is in fact B. The first option that I had it's marked in fact. Okay. So this is the correct answer. There's that I think there is a 4 missing in the option. It should have been a 4 here. 4Gmm over 4r square minus L square. That is the correct answer. Boom, you can see where you went wrong with your calculation. Okay. Please try and find the mistake with your calculation, and it should be easy to see. Okay. This is how you will approach this. All right, next is acceleration due to gravity, but today we seem to have run out of time. So this is where I will wrap up today's session. We will discuss about acceleration due to gravity in the next class. In fact, okay. So our time for today is up. I hope it was a fine discussion so far. Okay. So again, before I leave you, let me remind you that if you haven't gotten your Unacademy subscriptions yet, you should be getting them. So there are a lot of benefits, and I think for such benefits, you should definitely get that subscription, especially for a competitive exam like IIT JEE. I keep telling you guys. So 10 lakh people are taking this exam. Only top 1% finish or reach IITs. So if you're really serious about this aim of reaching to IITs, you want to finish in the top 1%, and that is not going to be easy. Okay. प्लस पे मिलते हैं एकदम एकदम शिवम. Okay, so that is not going to be easy at all. Trust me, you will need all the help that you can get, and this is going to be a great help, this Unacademy subscription. So how do you get this Unacademy subscription? Go to the plus section of the app, select your goal as IIT JEE, and click on that get subscription. Don't forget to install the app and check out the free courses also. That is what you can try and see how it feels, how the experience of those courses is going to be. When you click on the get subscription button, you'll be redirected to the all right, bye bye, Shivam. You'll be redirected to the payment page where you will realize you can choose from two kind of subscriptions plus an iconic. In both these subscriptions, you can use this code RD Live. This will give you a 10% off on all your subscription fees. The fees of various timelines, various plans for various timelines is as shown. Now, most of you know about the iconic one, about the plus one. A lot of you don't know about the iconic subscription. So let's just quickly talk about that. The iconic subscription now, this is a new feature that Unacademy brings to you, and this will take your IIT JEE preparation to the next level. How? You'll be assigned personal coaches who will closely monitor and check your performance. So hi for education, long time. Sorry. Now, you will also be attending a lot of IIT JEE workshops. You'll be receiving expert guidelines from time to time. You'll have a study planner and you'll have test analysis, regular test analysis sessions, okay, with your iconic submission. Next, you can also compete in this Unacademy combat. This is a great opportunity to test your preparation, to compete with others, your peers, and also, if you do well, win some cool prizes. So the next event is going to happen on the 20th of December. You can compete live in that, and you can enroll now in this Unacademy Combat using my code. Okay, so if you have been watching my lectures, if you are confident about physics, I think if you have been watching my lectures, you should be confident about your physics, and you should be enrolling with this code and cracking that quiz. Okay. Now, if you like today's video, if you think it was a good revision and good bit of practice, then don't forget to press the like button and share it with more and more people. As I keep saying, this is quality content being given to you absolutely free by Unacademy, because Unacademy realizes that not every student can afford these subscriptions, and we at Unacademy believe that it is the right of every student to be able to access quality education. So make sure you're sharing this video so that more and more students can receive some quality education completely for free. And if you're new to this channel, don't forget to subscribe, and don't forget to press the bell icon. And PDF of all the slides used in today's lecture would be available for download very, very soon. Now, those of you following us on the JEE English channel of YouTube, don't forget to connect with us on the Unacademy, on the Telegram app of JEE English using this link. Okay. Next, this is my time for today. I will see you tomorrow, where we will resume this discussion, where we will talk about the acceleration due to gravity, we will talk about the planetary motion, and we will talk about potential energy, and everything else about gravitation. Okay, so for that, we will meet again tomorrow. Till then, go through today's lecture. Make sure you understood everything. If there is some part of today's discussion that you did not follow, make sure that's the first thing that you ask me tomorrow. Okay. Now, let me remind you one last time. This is the code that you should be using if you like my your dream colleges and dream ranks. Okay, so don't forget to use buy the Unacademy subscription using this code RD Live and enjoy a 10% off. All right. So I'll see you tomorrow with that. Okay. Till then, you guys keep studying, keep practicing, and to take care of yourselves. Bye bye.